Hi guys, welcome to my channel, and today we are going to solve another problem which is known as running time and complexity. So basically this problem is nothing, just we need to identify whether a given number is a prime number or not. That's it. So we know the prime number algorithm works in this way that if we are given a number 1, we are going to iterate from I equal to 1 or I equal to 2 till that number and compare if any number divides that particular given number, and if it does, that means the number is not prime. Otherwise we can say that the number is prime. So the problem is that we are going to do is we are making n comparisons, right, till n. Can we reduce this comparison? That's the question here. So here basically I'm taking the input. If you look in the program, I'm taking the input from in, then I write as in test case sc dot next, which means that the number of test cases which is here equal to 3, and then I am running the for loop. Like for each of this number 12, 5, 7, I have to identify and whether this number is a prime or not. So here a simple for loop has been written, and inside this I'm going to call a function which is known as get prime. Pass that number if this method returns a boolean variable true and false. Accordingly, what we are going to do is whether we are going to print whether the number is prime or not prime. So this is the algorithm. So now let's focus, as I mentioned, that we are going to make a comparison, right? So let's start coding, and the coding is simple once the hint is already given in the problem. Okay, we'll come to, just remember that the hint is given as order of square root of n. Like if we are making some changes in our code, so that instead of making, when we are comparing and running the loop for n order of square root of n, can we do it in such a way that we do not, instead of making n comparison, we make, we when we are checking, we check it for square root of n instead of n. That's the question here, and that will help us to reduce the time complexity of the problem. So let's write our code. So first of all, our first loop will be that if n is less than 2, that means obviously this is not a prime number, we just return false. Okay, that's it. Now we are going to write a comparison for I equal to 2, right? I equal to 2, I less than n, I plus plus. Okay, so now what we are going to do is that if n mod I equal to 0, that means any number is divisible, is able to divide the number 9, that means we return false, it's not a prime number. Else what we are going to do is that we are going to return our method as true. By default we are returning this number as true. So now here if you see that here we are making comparison, right? What we are going to compare, that if any number is able to divide till from, so usually what we are going to do, we are going to write our code like this, right? But okay, any number can be divisible by 1, so we can do is 2. Now here if you see, can I reduce the comparison here? So if here this point is square root of n, and now the problem comes, how do we come up with the square root of n? So the easiest solution will be, just while making the compare, I square this number, right? Mathematical algebra, and this, let me make this thing I equal to 2 less than equal to n. So if I am making I square square, it becomes that okay, instead of square root of n, I'm just saying that okay, square root of I, just square the value of I, and the number of comparison will get reduced and the results will be same, right? So for example, if a number is 7 and we are going to divide by 3, so instead of 3 we are saying that 3 3s are 9, or 2 2s are 4, if I loop is 2, then 2 into 2 is 4, 4 is less than equal to 7, right? Then we see that okay, whether we are able to divide or not, we return false. If so simple, this problem is like 2 into 2 is 4, but if we divide 7 by 4, the remainder will be 3. So this loop will, we will be getting as 2 for prime number 7, right? So instead of comparing with 2, I was making the, actually running the loop from 2 to 4, and I was reducing the comparison not to do with number I equal to 3. You can say the next loop will be running from 3, then we are making the comparison till I square equal to 9. So what we are going to do is that we are, instead of making square root of n, we are just increasing this I square into I value, so that the comparisons are less. Let's run the code. So many errors. What is wrong? So first is saying that illegal part of the expression public static boolean get prime int n. It's saying we cannot define this as a public. So the problem may be lying here. Let me make this up. And yes, now let's run this code. This line number 35. Okay, I need one more square. Curly bracket. Let's run again. So basically this is what I want, like these guys to provide, HackerRank needs to provide Java proposals, so that these kinds of stupid issues which come due to compilation, just a typo mistake can be removed. The ID itself can throw an error. Like when we are coding into Eclipse ID, Eclipse provides us a very good Java proposals, and when we are writing or making a typo mistake, and obviously we cannot remember the entire Java JDK library functions, it provides us Java proposals. Like for a particular library, these methods are available, and then you can select it, and your coding efficiency increase. So I highly recommend Eclipse ID or Spring Suite ID, which I use personally, Spring Tool Suite 4, because I do a lot of coding in Spring as well for Spring framework, but here we are not using any Spring, we are just using Java, plain Java coding. So but in this case also, I recommend that HackerRank should increase their interface so that they can provide us Java proposals easily. So you see that okay, our algorithm has passed, our code has passed, we are able to solve this problem. Let's the submit code and see all other test cases are passing or not. So all of our test cases have passed successfully. I hope you appreciate this problem, and it's a simple problem, right? Basically, we are just getting to know how we can reduce time complexity of an operation, and we were able to do by making of order of n comparison to making an order of square root of n comparison, right, with this line, if you see. So I hope you like this video. Please do share this video, subscribe to my channel as well, so that whenever I upload a new video, you get an click on the bell icon so that you are notified that okay, I have posted a new video. And guys, keep commenting on the video if you like, and just share them. If you want me to solve any problem, just ask me over a video, just comment on my on the video, and I'll solve that problem for you. If you have a different solution for this problem, do comment that as well. I would love to see if you have any different solution of this problem, and I really appreciate that, guys. Thank you guys, bye.